I've spent 8 years running fabrication labs where kids as young as 8 fire up their first 3D prints, and I've seen every possible safety scenario. Some hilarious, a few genuinely scary, all of them instructive. Most of the panic you'll read online about 3D printing dangers is massively overblown, but there are real hazards that matter, and knowing which is which makes all the difference. I'm Kazuki Tanaka, and I'm going to walk you through the exact safety framework I use when auditing makerspaces for insurance compliance.
You're listening to the STEM Lab podcast. Quick note before we get started. Everything you're about to hear, the research, the data, the script, that's all written and verified by real people, real authors with real expertise. But the voice you're hearing, that's AI generated. Just want to be upfront about that. Now, if you've been listening for a while, genuinely, thank you. It's easy to skip episodes or let a show fall off your rotation, so the fact that you're here means something. And if you're new, hey, glad you found us. We release new episodes every Monday, Wednesday, and Friday, covering science, tech, engineering, and math tools and topics for kids and teens. All right, here's what we've got for you today. This checklist covers the essential physical, electrical, and operational safety measures you need before your young maker hits print. Whether you're setting up your first printing station or just want to know what hazards actually matter, I've organized these by environment, equipment, materials, and supervision protocols. Same system I use in professional settings. Your workspace determines about 80% of your safety outcomes. I've seen families skip this step and end up with a printer on a wobbly card table next to a curtain. Not ideal. Place your printer on a solid table or desk that won't wobble during print movements. The surface should handle temperatures up to 80 degrees Celsius without warping. That's your heated bed temp. For younger kids, ages 8 to 12, position the printer so the build plate sits roughly at their chest level. This prevents them from reaching over hot components. I use a dedicated steel workshop table, but a solid wood desk works fine if you add a silicone mat underneath. Maintain at least 15 centimeters of clearance on all sides for air circulation and access to controls. Keep the printer 1 meter minimum from curtains, paper storage, or anything flammable. FDM printers exhaust heat. I've measured ambient temps 10 to 15 degrees Celsius higher within 30 centimeters of an operating printer. Most entry-level printers draw 200 to 300 watts during heat-up, comparable to a desktop computer, but larger models with heated enclosures can pull 500 watts or more. Use a grounded outlet on a 15-amp circuit that isn't shared with high-draw appliances. I've tripped breakers by running a printer, laser cutter, and space heater simultaneously. Learn from my mistakes. If your workspace has concrete or tile flooring, add a rubber anti-fatigue mat. This prevents static discharge issues, rare but annoying, and cushions dropped tools. More importantly, it defines the work zone visually for younger kids. It's a behavioral cue that says, this is the makerspace, pay attention here. Install task lighting that illuminates the build plate from above and slightly to the side. You need enough light to inspect first layers and spot failed prints early, but avoid direct overhead lights that create glare on touchscreen interfaces. I use a swing arm LED desk lamp with adjustable color temperature, warm light for supervision, cool light for detailed inspection work. Mount a 2.5 kilogram ABC or BC rated fire extinguisher where kids can't accidentally discharge it, but adults can grab it instantly. I've never needed mine in 200+ hours of supervised kid printing, but the one time a power supply failed and started smoking, I was grateful it was there. Check the pressure gauge monthly. This is a good recurring task to assign to teens learning lab maintenance. Install a photoelectric smoke detector directly above or within 1 meter of the printer. Test it monthly. Some filaments produce visible fumes during printing. Your detector shouldn't false trigger constantly, but it should catch actual thermal events. If you're getting false alarms, you have a ventilation problem, not a detector problem. Keep a basic kit with sterile gauze, burn gel, Tweezers for removing stuck filament from skin, yes, it happens, and bandages within arm's reach. Most 3D printing injuries are minor, touching a hot nozzle, pinching skin in moving parts, or small cuts from removing prints with scrapers. I've treated dozens of minor burns. None required medical attention beyond cool water and aloe. Now, let's talk about printer equipment and hardware safety. Hardware safety starts during printer selection and continues through daily operation. These checks prevent the majority of mechanical injuries. If your young maker is under 14 or prone to distraction, invest in a fully enclosed printer. Check the link below to see current prices on models like the FlashForge Adventurer 5M Pro. The enclosure prevents fingers from reaching moving belts, hot nozzles, or the heated bed during operation. I've watched kids instinctively reach for a cool-looking print mid-job. Enclosures eliminate that risk. Open-frame printers are fine for focused teens 15 and up, but require stricter supervision protocols. Verify your printer has a physical emergency stop or power cutoff button that halts all movement instantly. Test it before every new user's first print. I make kids demonstrate they can hit the stop button with their eyes closed. Muscle memory matters when they're startled by a sudden movement or noise. A poorly leveled bed can cause the nozzle to dig into the build plate or collide during homing. For manual leveling printers, teach kids the paper drag test and supervise their first 5 to 10 leveling sessions. Auto-leveling printers reduce this risk, but still need periodic verification. I've seen nozzle crashes crack glass beds. Scary, but mostly an equipment hazard rather than a personal injury risk. Mark high-risk zones with colored tape or labels. I use yellow electrical tape to outline the danger zone around moving Y-axis beds. It's a visual reminder not to place hands there during operation. For open-frame printers, add 3D printed belt guards. Ironically, one of the best first safety projects for teens to design. Configure your slicer profiles with maximum temperature limits. For PLA, cap hot end at 220 degrees Celsius and bed at 70. Kids learning filament types sometimes assume hotter is better and crank temps unnecessarily. Use slicer parental controls. Cura has a custom mode lock to prevent unauthorized temperature changes until they understand the fundamentals. Before starting any print, verify the filament spool rotates freely and the feed path has no kinks. Tangles can cause extruder jams, which lead kids to help by pulling on hot filament. That's a common burn scenario. I use spool holders with bearings rather than friction holders. The small upgrade eliminates 90% of tangle-related issues. Check that thermal runaway protection is enabled in firmware. This shuts down the printer if temperatures exceed safe thresholds or the thermistor fails. Most modern printers ship with this on, but budget models sometimes don't. If you're teaching teens to flash custom firmware, Marlin or Clipper, make thermal runaway one of the first concepts they learn. I've tested this by simulating a thermistor disconnect. The printer should halt within 15 seconds. I mandate safety glasses during print removal. Flying print chunks or snapped scraper blades are the most common sent to urgent care events in makerspaces. Polycarbonate safety glasses cost less than a single roll of filament. Even if you're using flexible build plates, which reduce scraper use, enforce the habit. This prepares kids for proper PPE protocols they'll encounter in professional fabrication environments. Moving on to filament and material handling. Different filaments present different hazards. I've run comparison tests on fume emissions, dust generation, and handling risks across all common materials. PLA produces minimal fumes, mostly lactide monomers, which are relatively benign, prints at lower temps, 190 to 220 degrees Celsius versus 230 to 260 for ABS, and doesn't require heated enclosures. It's biodegradable, but tough enough for most learning projects. I restrict kids under 16 to PLA exclusively, unless they're in a supervised advanced course. ABS emits styrene fumes, not immediately dangerous but unpleasant and potentially problematic with extended exposure. If printing ABS is necessary, it has superior mechanical properties for functional parts. Use a printer with a HEPA and activated carbon filter, or place the printer near an open window with a fan exhausting air outside. I've measured VOC levels with an air quality monitor. Unventilated ABS printing in a small room spikes readings noticeably. PETG is gentler but still warrants ventilation. Moisture-absorbed filament, especially nylon and PETG, causes print failures, excessive stringing, and popping sounds during extrusion. Kids often investigate by getting too close to the hot end. Store filament in airtight bins with rechargeable silica gel packs. I check hygrometers inside storage bins monthly. Target below 20% relative humidity. This is also a good opportunity to teach teens about material science, how hygroscopic materials behave, why moisture matters for dimensional accuracy. Carbon fiber-filled filaments require hardened nozzles. Standard brass wears out quickly and produce dust when trimming supports. Mandate masks and ventilation. Glow-in-the-dark filaments contain strontium aluminate particles that are mildly abrasive and can cause nozzle clogs. Supervise their first use closely. I introduce these materials only after a student has logged 50+ hours with PLA and demonstrates consistent safety practices. Establish a no food or drink within 1 meter of the printer rule. Hot-end temps can vaporize filament additives and colorants. You don't want hand-to-mouth contamination. I enforce this strictly even though the actual risk is low. It's about building clean room habits that transfer to professional environments, like electronics labs or clean rooms, where contamination has serious consequences. Some filament colorants contain trace heavy metals, especially older bright reds and oranges. Quality brands have mostly phased these out, but you may encounter them in discount spools. After print removal, tool changes, or maintenance, wash hands with soak. This is basic shop hygiene that kids need to internalize before they move to more hazardous fabrication tools, laser cutters, CNC routers, soldering. Now for operational and supervision protocols. Hardware and environment are easy. Enforcing behavioral safety is harder. These protocols have evolved through hundreds of hours of supervised kid printing. For elementary-aged makers, ages 8 to 11, an adult should be in the same room and visually check the printer every 5 to 10 minutes during operation. They don't need to hover constantly, but they should catch first-layer failures, filament tangles, or a kid reaching toward moving parts. This age group can load designs and start prints, but shouldn't troubleshoot hardware issues independently. Teens can handle more independence, but the first layer is when most failures occur. Adhesion issues, crashes, warping. Stay in the room while the first layer completes, then check back every 30 minutes. If they're using slicer software independently, review their settings before they hit print. I've caught multiple instances of accidental 300 degrees Celsius bed temperatures or 5,000 millimeters per second print speeds. Typos happen. Once a teen demonstrates consistent safety practices and successful print completion, allow them to start supervised prints while you're elsewhere in the house, using a Wi-Fi camera or the printer's built-in camera feed. Set up alerts for print completion or errors. I use a cheap WiseCam pointed at the build plate. $25 buys significant peace of mind and lets me verify remotely that they're following protocols. Before hitting print, users must verbally state material type, expected print duration, first layer temperature, and when they'll check progress. This 30-second review catches most setup errors and forces them to think through the process rather than just clicking print. I adapted this from aviation's pre-flight checklist concept. It feels formal at first, but becomes automatic and prevents careless mistakes. This is my hard rule. Overnight prints are convenient for long jobs, but they require trust in the equipment and the user's preparation. After 50 supervised hours, roughly 3 to 6 months of regular use, evaluate whether they've demonstrated consistent safety practices, proper leveling, temperature verification, filament checks, workspace tidiness. If yes, Allow overnight prints with remote monitoring. If they're still having frequent failures or skipping safety steps, delay this milestone. Teach users to pause, not stop, prints if they notice problems, weird noises, stringing, layer shifts, or strange smells. A pause preserves progress and lets you troubleshoot. Hitting stop wastes hours of printing. Practice this during a supervised print. Simulate a filament tangle and have them demonstrate the pause procedure. I've seen kids panic and yank the power cord. Bad. You lose your print and risk Z-axis misalignment. After print completion, wait 5 minutes for the hot end to drop below 50 degrees Celsius and the bed to reach room temperature before removing the print. Many kids see print complete and immediately grab the part. PLA at 60 degrees Celsius feels lukewarm but can still cause surface burns on sensitive skin. The printer should display nozzle and bed temps. Teach them to check these before touching anything. I've added a printed label above my printer that says, "Wait 5 minutes after completion." Kids are resourceful, which sometimes means using a kitchen knife to pry a stuck print. Mandate proper tools. Metal or plastic scrapers for print removal, flush cutters for support removal, needle nose pliers for pulling failed prints from the nozzle. I keep a dedicated tool set at each printer, labeled with colored tape. Using proper tools reduces injury risk and teaches them that professional makers don't improvise when proper equipment is available. Let me give you the technical safety requirements, the infrastructure checklist I use when setting up makerspaces. You need a 120-volt, 15-amp grounded outlet. GFCI protection recommended if you're in a garage or basement. Power strip with surge protection, minimum 1,000 joule rating. If your printer draws more than 400 watts, dedicated circuit. For ventilation, minimum 2 complete air changes per hour for PLA in enclosed spaces. Open window plus fan or HVAC return vent within 3 meters. For ABS, increase to 4 air changes per hour, or use localized filtration. Wi-Fi or Ethernet for remote monitoring. SD card backup for offline operation. Verify firmware update capability. Safety patches matter. Look for modular design, allowing addition of enclosure, filtration system, or upgraded hot end as the user advances. Printers that lock you into proprietary filament or restrict hardware modifications limit long-term safety improvements. Metal frame, not acrylic, for printers used more than 10 hours per week. Bed surface that survives 200+ print cycles without degradation. PEI, powder-coated steel or glass. Avoid cheap build tack clones that peel after 20 prints. Here's a condensed checklist you can print and post at your printing station. I've laminated mine and attached it with magnets to my printer frame. Before every print, verify workspace is clear of flammables and work surface is stable. Printer firmware current, thermal runaway protection enabled, correct filament loaded, PLA for beginners, and spool rotates freely. Bed leveled, first layer adhesion verified, appropriate temperatures for material selected, safety glasses and scrapers within reach, fire extinguisher in place, tested this month, supervising adult identified and briefed on print duration, first aid kit accessible, burn gel fresh. During the print, check every 15 to 30 minutes. First layer adhered properly, no warping or lifting, filament feeding smoothly, no tangles or binding, no unusual noises like grinding, clicking, or scraping, temperature stable within 5 degrees Celsius of target, user maintaining proper distance from moving parts. After every job, verify printer shows temps below 50 degrees Celsius before touching anything. Parts removed with proper tools, scrapers not knives, work area cleaned, scraps disposed of properly, filament returned to sealed storage with desiccant, hands washed after handling equipment, print logged, duration, material, outcome, and issues. Let's cover some frequently asked questions. What age can kids safely use a 3D printer with proper supervision? Kids as young as 8 can successfully operate an enclosed 3D printer with direct adult supervision, starting with pre-sliced designs and PLA filament only. They'll develop design skills through programs like Tinkercad and Fusion 360 while you manage printer setup, temperature verification, and print removal. By ages 12 to 14, most students can handle complete workflows independently with periodic check-ins. And by 15 to 16, responsible teens can manage advanced materials and overnight prints after logging sufficient supervised hours and demonstrating consistent safety practices.
Do we need special ventilation for printing PLA filament or just for ABS and other materials? PLA produces minimal fumes compared to ABS or nylon, mostly lactide and sweet-smelling compounds. But proper air circulation improves comfort and long-term air quality, especially in small rooms. For PLA, an open window or standard room ventilation suffices. You don't need specialized filtration unless printing 20+ hours weekly in an enclosed space. Upgrading to materials like ABS, PETG, or TPU require active ventilation, with a fan exhausting air outdoors or a printer-mounted HEPA carbon filter, since those materials emit styrene, volatile organics, or other compounds that build up noticeably in unventilated rooms. Can kids use 3D printers unsupervised once they've learned the basics, or do they always need adult oversight? Unsupervised printing depends on age, experience level, and your risk tolerance, not just knowing the basics. I recommend direct supervision until age 12, same room presence for the critical first layer for ages 12 to 14, and remote monitoring for experienced users 15 and up who've logged 50+ hours with zero safety incidents. Even then, establish clear protocols: what materials are approved, maximum print duration without check-ins, and exactly when to pause and ask for help. Professional fabrication labs require operator certifications for a reason. Apply similar progressive independence rather than treating printing as a binary supervised or not decision. The three most common safety mistakes I see families make are treating 3D printing like a plug-and-play appliance. It's not. It's a fabrication tool. Skipping environmental setup because the printer seems safe, and pushing kids to independence too quickly because they're excited and capable with design software. Safety, capability, and design capability develop at different rates. Build your protocols around your specific child's focus level and maturity, not just their age or technical skills. I've supervised focused 10-year-olds who needed less intervention than distracted 14-year-olds. The safety checklist I've outlined here isn't about preventing all possible problems. It's about creating a framework where problems that do occur, and they will, filament jams, failed prints, minor burns from impatience, become learning experiences rather than dangerous situations. Your goal isn't zero risk, it's appropriate risk with proper controls. When your teen can correctly diagnose a failed first layer, pause the print, adjust Z offset, and resume without calling for help, while wearing safety glasses and waiting for proper cooldown, they're not just learning 3D printing, they're learning the safety mindset that carries into every fabrication skill they'll encounter next: laser cutting, CNC routing, electronics assembly, and eventually professional engineering work. That capability is the real outcome you're building.
That's it for this episode of the STEM Lab podcast. Thanks for listening all the way through. New episodes come out every Monday, Wednesday, and Friday, so there's always something fresh coming your way. If you found this useful, I'd really appreciate it if you could leave a 5-star rating and write a quick review. It's one of those things that actually matters. It helps other parents, educators, and makers find the show when they're searching for this kind of content. And if you haven't subscribed or followed yet, do that now so you get notified the second a new episode drops. Catch you next time.